Okay, let's go ahead and get this going. So howdy y'all, I'm Joe Houghes. I'm here to give a presentation entitled GitHub Actions to Automate Multi-Cloud Deployments. This is all about taking your Terraform to the next level. In this instance, just because we had to kind of squeeze things in for demo time, this is actually going to be just a deployment against VMware Cloud and AWS, and we're going to actually kind of run through this in two parts. One, I had to provision an SDDC earlier because it takes about 2 hours, but we'll see how everything works all the way through. So again, I'm Joe Houghes, currently solutions architect at Veeam Software. And basically I'm the guy for automation and integration, but I just like playing with things. I'm a community geek. I'm one of the co-leaders for the Austin PowerShell and VMware user groups. Typically you can find me with the green hat, the big grin, and the loud howdy y'all. Playing with the team today, so I'm wearing my VMware gear as opposed to the green hat for once. As you can see here, I have little shame and just try and share my learning with others. So if you guys can learn things from my mistakes, whether they're live or in the code, then hopefully I can help you guys out. So the tools we're going to be using today for this is going to be primarily just GitHub Actions and Terraform, right? So for GitHub Actions, we're really going through this to try and show everybody how to automate their code workflow. So in this instance, we're going to be using this as CI/CD that you don't host, right? We're just going to be triggering some of these actions based on events within the GitHub repository. GitHub Actions are also extensible by your own actions. So you can create your own actions in whatever language is comfortable for you and tie these to whatever you're doing with your code. And the other benefit of this is chances are you're already using GitHub, right? For Terraform, who doesn't know Terraform? It's a fantastic open source infrastructure as code tool. It must be great if, Kyle Ruddy and Cody D'Arclin went to go join the team. Everything functions around HashiCorp configuration language. It's very easy to read, human consumable code that you can write. Everything is driven by declarative config files. So all of this is about being idempotent. This means no matter how many times it runs, you should get the same desired result out of this. And then all of this is built on providers for resource dependencies. The real power of this is that the folks that basically own those systems that this is connecting to can manage those providers. So updates to HashiCorp, bits on the back end, updates to Terraform itself don't affect what you're doing with your providers, but new functionality inside of your providers doesn't have to wait for a new update to Terraform to come through. So how we're going to use this in this example, right? This is going to be a very simple task 1, 2, and 3, right? Task 1, we're going to go through and we're going to create a new SDDC in VMware Cloud on AWS. Task number 2, we're going to create some NSXT firewall rules. And then task number 3, we're just going to provision a VM inside of that environment. So simple tasks that we're doing here. This is more about the flow and how we're actually using the system. So we're going to drive all this through pull requests, which means we're going to actually be testing this with branches. So we'll cover a little bit of Git 101 for anybody that's not using it. We'll do some at the CLI, we'll do some within the UI. And then to actually make these changes run, to apply these, it's going to happen when we do a push to main. And we're going to get that by doing a merge of the pull requests. And then for an action that we have for manually destroying the environment, I have this not wired up to any sort of automated action. It's a push button. So I know people are not going to like that you have to push the button, but that also means your environment's not going to get destroyed before you want it to. Other components that we're using inside of here are going to be GitHub Secrets, and we'll cover these when we actually look at the settings for the repository. And then Terraform Cloud. We're using this and leveraging it as a remote backend for the Terraform state only, which means that when we create that workspace, we actually need to go in and change the general settings to be local execution mode so that Terraform Cloud understands we're not actually trying to use Terraform Cloud for running any of these workflows. It's just holding our state file. The other things, just for clarity of what we're using here in the demos, VS Code, Terraform on a test box just for testing and fixes locally, and then the GitHub GUI. So with that, let's go ahead and take a look at what we actually get from the benefit of this thing, right? The real magic in the end of this comes from additional things you can do with this workflow. Here's just a couple of quick screenshots, one from my phone for a notification that actually came in through the GitHub app. And then on the right side, we've got the GitHub app itself and what shows when we ran a pull request to our environment, and it actually goes through and Terraform is running, like verifying our formatting and style. It's doing an initialization. It's running a validation of our TF files, and it's telling us whether we had a success or failure for our plan. And then we get the full output for what the plan is for this environment. The nice thing, this example on the left is actually coming through from Pushbullet that I have set up on my desktop. So when this notification hits my phone, it gets mirrored to my desktop. So if I'm sitting here and not staring at GitHub, or if I'm, walked away and have gotten a cup of coffee, I can still see what goes on within a couple of minutes, or I have an idea, of how long a workflow should take. And if I don't get an update, then it's basically going to eventually come through and tell me, oh, you screwed something up and something failed. So let's go ahead and flip over to our demo box real quick. Okay, so hopefully everybody can see the demo box. I tried to zoom in a little bit on this thing. So just to start off, again, what we're working with here is going to be VMware Cloud on AWS. So within this environment, as I told you all before, I already have a pre-provisioned, I called it a pre-baked environment. Basically, we're going to do some of the TV magic, right? We're going to go through and we're going to create the batter, get this thing working once, and we're going to throw it in the oven and swap out the one that's already done. I have an SDDC that I deployed earlier on VMware Cloud on AWS, again, just because it takes about 2 hours to provision this thing. I did end up running into an error at the very end where my SDDC got provisioned, but Terraform gave me back some output that it could not provision me a public IP address for some reason. So hopefully the second part of this actually runs properly. But as we can see here, I've got an SDDC, which is just titled Terraform-SDDC. This is going to be a single node cluster that exists out here. So we're going to provision a 2-node kind of live and interactively here, primarily because of the fact that we can only have one single node cluster inside of the environment is just a restriction that we have here. Plus, I'm cheap. This is coming out of my pocket. So what we're going to take a look at next is going to be our GitHub repository. And within our settings on the repo itself is where we're going to find the secrets that we have inside of here. So within this, I've got my code wired up to pull my AWS account number for all the things it needs to get out of AWS, primarily my VPC and my subnets. I've got my Terraform Cloud API token, which is what's giving me access to the workspace on the back end for holding this state. I've got my API token and my org ID for VMware Cloud. So this is just what's actually giving me access within the console to make the changes that I need to and provision that new SDDC. If we take a quick look over at our workspaces on Terraform Cloud, we have a workspace. All of these are just provisioned under a single organization that I've got here titled for this demo. And then I've got 2 different workspaces. One, which is the pre-bake environment that's already existing. And as you can see, we've got a state file that's in here. So this will give us all of our information back, shows us, it ran against Terraform version 14. It's got all the info about our existing VMC SDDC. But if I go into the other workspace that I've got here for my live demo, you'll see we have nothing, right? This hasn't had anything run against it. It was just a new workspace provisioned for this. So we can go ahead and get back into our repository, and all I have here set up for these workflows so far are one workflow, which is going to be our automated Terraform job, right? So within this workflow, again, titling it automated Terraform workflow, it's only going to run on a push to the main branch or on a pull request. That's the only actions that are wired up for this. Let me go ahead and zoom in a little so everybody can see a little bit better on this. So all the power within this job is within all of these steps that are defined here. So I have this job defined to run against an Ubuntu latest. So this is going to run against a hosted GitHub Actions runner that's going to be living out in the cloud. It's just going to declare it's going to run the bash shell. The first step that runs is the action that exists from GitHub to just check out the repository, right? That's all it's simply doing is getting our code in here. The next thing we're going to do is set up Terraform. So HashiCorp has this GitHub Actions that's out here that's set up Terraform. And essentially this will install the latest version of the Terraform CLI. And because we're giving it a credential for the Terraform backend, and we've determined that we're going to connect to a remote backend for this, it's going to make sure that it can connect to Terraform Cloud and validate that. The next thing we're going to do is just an init. We're just going to initialize our Terraform files and make sure that we are initializing everything that we've got in here, loading any remote state that exists, or downloading any of the providers that are missing. Then in these couple of steps here within this echo statement, this is me just listing out that once we've completed some of these steps, we can actually get access to these outputs and put them in here, or can feed them out to our pull request if we want. However you want to do this, you have access to all steps and all input and output throughout these workflows. So you can leverage this any way you want through your jobs. The next thing we're going to do is just a quick format. This is really just putting everything into canonical format and making sure that the formatting from one version of this file to me making an edit into the next one lines everything up properly. So it's a lot easier to see on a diff check from GitHub itself without digging into Terraform or actually needing a linter for it. Then we're going to just do a simple validation. We're going to do a plan. And this plan is leveraging, again, our VMC API token, our VMC org ID. And then if we scroll over to the right here, we've got a variable for our AWS account number. So that's where we're actually leveraging those secrets that are being piped in directly from GitHub. So they're not contained in our code because nobody wants to be the guy who's leaving, passwords in plain text. Once we have this plan run, the next thing we're going to do is run a script action within this workflow. So this job, if it makes it all the way down to the plan and it says that this GitHub event that triggered it was a pull request, if the plan was successful, it's going to give us back all of this status information, right? It'll give us the output or the outcome of our formatting and style, the initialization, our validation and plan. I actually have these commented out, so we're not going to get all of this. What it will give us is all the details of the plan in a summary, and it will give us the full list of details. So we'll have a couple of pages of stuff to scroll through here. And then it tells us, who was the actor, what was the event name, what's the working directory for all of these Terraform actions. And then you can even do things like creating an issue based on anything that came in this job earlier. If all of this succeeds and this is a push on our main branch, then we're going to run the Terraform apply. And we're just doing this with auto approve because at this point we've said everything is good. We've validated that everything worked correctly in the plan, and we've accepted our pull request, merged our pull request to go ahead and have a push to the main branch. So that will go ahead and kick off our workflow. So that's everything that we have here in the job. Essentially, it's the same exact thing if you look at the workflow for the manual destroy. I will just show everybody that the thing that we have here is just that the destroy step itself, sorry, I'm trying to find where I have it tagged in here. Whoops. Oh, I'm sorry. It's up here on workflow dispatch. By saying that this is a workflow dispatch, this means that the workflow itself is going to give us essentially a button that says run this workflow. Sorry, I was just losing where that was in the code right now. So we have nothing in this repository itself. So we'll go ahead and flip over to the command line and take a look. So if I look at this directory, we have nothing in here. We look at our Git status and we're up to date with our main branch from above. So what we can do here is, let me go ahead and close these and reopen these files because I'm pulling all this in from just a source directory where I've been working on the Terraform files themselves. And if we want to actually go ahead and run this workflow, what we're going to do is we're going to get these pushed up to GitHub. Okay. Yeah, Conrad, I see your question about sharing the GitHub repo. I will put this up available later. I will also add some additional code from some workflows for doing similar things on Azure and AWS. So this will be available later on for people to take a look at. So within this, not to get into Terraform itself, because the point of this session is not really learning Terraform. It's not running the Terraform code. It's more about the workflow and how to get GitHub Actions to work with things that you're doing already in code, right? So we're going to assume this is a functioning workflow that we have for creating an SDDC, for adding the NSXT rules, and for provisioning a VM inside of our environment. So here we have just our traditional variables file. We're defining all of these. We've got our auto TF vars just so that this automatically loads when this workflow runs. So we're going to create a new SDDC titled Terraform-live deploy. We're going to say actually that this thing is going to be a two-host, two-node cluster, and I need to make sure that I have this. Yep, I need to comment out that this is going to be a one node because this is what I used for earlier. Okay, for the other question about the CLI that I'm running here, this is actually just Windows terminal. It's just got a scheme, a color scheme in here for doing this. So I will make that available if anybody wants as well. But again, all we're defining here, right, just a name for SDDC, how many nodes we're going to have in this cluster, where we're going to put this for a region within AWS, what's the sitter for our VPC, and then what's the subnet for our VXLAN, and then a name, a display name for our public IP. So we will take all of these files that we have here, and we will go ahead and just drop them into here. And if I run a git status again, we'll see we've got 3 new files. So I'm going to go ahead and do a git add. Oops, actually, I should do this properly. I'm going to check out a branch and we're going to call it create SDDC. Okay, so now we're in our create SDDC branch. I'm going to do a git add of all files. We're going to go ahead and do a git commit. You know what, I'm just going to cheat and I'm going to go ahead and copy my commit messages so I don't fat finger this when I'm running it live. Okay, so we've committed with a commit message of just creating our SDDC. So now we're going to go ahead and push. So we're going to git push origin. What did we call this? Create-SDC. Okay. So pretty quickly, we're going to see that this starts pushing back up to GitHub. When we come back up to our repository itself, we can take a look at this. And we can see that we had pushes on this create SDDC branch just now. So we can do a compare and a pull request on this. So I can say, okay, I've got a commit message on this, sure. So we're going to do the thing. We're going to create a pull request. And now from this pull request, what we're going to see is that we're going to have the GitHub Actions trigger on this, and it's going to give us this job request that's going to show here in a running status. So if we go into details here, we can take a look at this and see what happens. Now I have a couple of places in here where I'm expecting this to bomb because I have intentionally set this these things up with some failures for this live run through. So the first thing here that we're running into is that I was just declaring VMC as our provider that was running here. But at the beginning of September, there was an update to the VMC provider. So this transitioned from being HashiCorp/VMC to now Terraform-providers/VMC. So it tells us here that it tried to run, and at the init stage, it failed, right? But the error that we got back from Terraform is just an exit code 1. But Terraform just being very verbose on what it was actually doing in these steps, it tells us, hey, if all this looks correct based on this error for the failed to install providers, you can just run this. So we're going to go ahead and copy this code for this Terraform 0.13 upgrade, and we're just going to run this interactively, right? So we can say everything looks good. Yes, I want to run this. So what does it actually do here? This is just going to give us a versions.tf file that's going to show that it's got an instance defined a little more clearly for which provider we're using on the back end. So if I open this up inside of VS Code, all it's doing is specifying for us that the VMC provider, which had an ambiguous name, is actually getting directed to Terraform-providers/VMC. And it just gives us, again, our required version of greater than 13 that we're running here. So all this looks good. We're going to go ahead and do another git add. So we have everything in here. We're still on our create-SDDC. So I'm going to commit with just a message of adding the version TF after the upgrade. We're going to go ahead and push back to origin yet again. Okay. So now that we have this up here again, I can come back to my pull request. And inside of this pull request, we'll see I've got another merge. I've got my commit message on this, and it's triggering the workflow yet again. So now if I get into this workflow, it should show me that I make it one step further in the progression. It should make it past the initialization, right? So it's checked out our code, it's set up Terraform, it's run the init, everything looked good. Oh, it doesn't like my formatting on the file. And all this is just because I've got a tweak in here where I have an extra space, and that's not what it likes when it runs that Terraform FMT. So what we're going to go ahead and do here is we're going to run a Terraform format, and I'm going to do a check on this. Okay, so it tells me the only thing it had a problem with was that main.tf file. So if I run check with diff, it'll show me what the difference is. And in here, you can basically see it's a little bit hard with the code, but you can see that the only difference here is that it had one extra space in front of the equal sign, right? So now all we want to do is go ahead and run the actual format, let it format the file. We'll run another git status. We'll see that it's modified that single file. So we will do another git add for everything. I'll go ahead and add another commit message where I'm updating my formatting. Okay, and then we'll do another git push. So if I remember this demo correctly, what should be happening at this point is everything should validate, and it should show us that it makes it all the way through the plan successfully. I don't think I modified this demo more than that, but we will see. Okay, so we've set up our job. We've done the checkout on the repository. We have the setup of Terraform itself. The init's good, the format's good, validate is good, the plan is good. It's giving us our steps for writing out the action for the, writing the output for the pull request. And everything here is good, right? We've got green check marks. If we look back at our pull request itself, what you'll actually see is that the bot goes and dumps back our information here, right? So right here, all I'm doing is just some emojis because I didn't want to have this filling up a ton of extra stuff. But if I look at the show plan, it'll give me back the full plan results from Terraform. So it shows us that what we're going to be doing here is we're going to be adding a new STDC. We're going to be adding a new public IP address, right? Those are our two objects to go through. So if I can say, okay, this all looks good. So we say, Joe finally did it right. If I can even spell that correctly, I will add a comment. I will say, this is good. I'm going to merge my pull request, and huzzah, this is good. I can even go through here and delete my create STDC branch if I want. But for now, all I really want to do is go ahead and take a look at our GitHub Actions. So we'll go back into our Actions menu. We'll take a look at our automated Terraform workflow, and we'll see that it's merging this pull request. So we're going to have one in progress job. This should be to the point that everything is validating in the plan by now. Yep. So the plan is good. It skipped writing the output because this is not a pull request at this point, right? This is us actually making a commit and a push to our main branch. So what it's doing here is it's actually doing the apply, right? It's going to create. I'm going to let it sit here for about maybe 20 seconds or so, and then we'll take a look at the VMC console, and we should start to see an STDC provisioning out here. And at this point, this is where we're going to basically like throw the batter in the oven, and we'll go ahead and swap out the other environment because we're not going to sit here and stare at this for 2 hours. As much as I know y'all would love to hang out with me that much on a Friday, it's not going to happen. Okay, 40 seconds elapsed. Let's see. QA, what do we have? Nope, no QA. Oh, Dan. All right, let's go ahead and refresh because this UI may just not be updating. Okay, so sorry, here we go. That's what it was. I should have just refreshed. So we have a new cluster that's getting provisioned here. That's our Terraform-live deploy. Estimated time to completion here is unknown from the VMC console, but you know, it's taken anywhere from 90 minutes to like 3 hours at a long run before. So we're gonna go ahead and say, this one's good, this one's done. We're gonna shut this down and we're gonna flip to our other environment. So what this looks like in the end, minus the one error message that I have inside of here, when this actually completes, what it should give us back is the results from our Terraform apply. And as you can see here, when I ran this earlier, we actually ran a little bit quicker than we have in the past. So it ran after about an hour and a half, and it created the STDC with no problems. But when it went to go create and designate a display name for my public IP address, it said it was an invalid request for some reason. Unfortunately, since I did this one just earlier today and didn't have time to tear down and reprovision the environment, we're going to have to try and see if this failure of the apply for just the public IP address ends up causing us issues when we try and apply our NSXT rules and create our VM. So let's see what happens. But inside of this repository, all I'm working with are the same TF-vars files and you know, my main TF and my declared variables. So this is the same 3 files that we used earlier just a minute ago to create that new STDC on the fly. So we'll go ahead and jump into this directory. And again, if we take a look at it, just have those 3 files inside of here. Let me go ahead and get this thing up. Let's see. Let me get this one closed for my pre-bake. So what we're going to do here in this one is go ahead and take a look at our files that we're going to work with next for our NSXT rules. So if I open these in VS Code, the only thing I'm going to go through and do here is actually change the allowed IP address, because what I want to do is restrict this. And we'll get into the details on this one in a second when I go into the console. For this main TF, again, we're just, declaring what it is we're looking at. We're going to go into the gateway policy. We're going to add a handful of rules that are defined inside of here. And essentially what I'm doing here to add this is I'm going to go create a new rule that I'm trying to find right now for ESXi. Yep, here we go. Sorry. So for my remote console and for my vCenter. And what I'm actually trying to do inside of this thing is just go through and define a rule to allow me to get in for vCenter on HTTPS, as well as getting in for my remote console service. So what I want to do for this is define a group which is going to actually be my allowed IP address that I'm bringing in from the internet. So let me go to I can't has IP. So there's Joe's IP address for everybody that's going to try and screw with me now. Feel free. Okay. So I will go ahead and update this file. We can close these three. And again, all we're going to do here is basically just go drop these files into our repository. But this time, I think what we want to do is, again, for those that are not super proficient at Git on the CLI, we're going to go ahead and just do this one interactively through the GUI and see how far we get. So let's go ahead and create a new branch. So we're going to create add-nsxt-rules. So I'm going to add a new branch. I'm on this new branch, and I'm going to say I want to go ahead and add some files. I'm just going to do a straight upload where I can just drag and drop these files in here. So we'll wait for these to upload. Okay, we got our three files. I'm going to go ahead and commit. This is going to commit to our branch for this add NSXT rules. We will see that this branch has had a recent push, so we can do a compare and a pull request. Let's see what happens. So I'm going to create a pull request for this. And at this point, again, we're waiting for our automated workflow to just pick this up and have the job trigger. So we'll go ahead and pull up the details, and we'll give this a second here because I want to see what happens when it actually gets to running a Terraform plan. I believe I kept this demo clean to where we should be able to just run it. Nope, I need to do a Terraform init. Oh yes, there was the change to the VMC providers is covered, but there was a change to the NSXT as well. It switched from a HashiCorp to a VMware. So we're going to do the same thing. So for this one, what we're actually going to do is we're going to go ahead and do a git pull on this pre-bake environment. Okay. So, oops. Oops. Come on, let me git fetch. There we go. Sorry, I skipped straight to a pull without a. Okay, add NSXT rules. Let's see if I stuck with names that I can actually remember. Switch to a new branch. Okay, so we can do git status. This will show that we're up to date with the working branch upstream. So what we're going to take a look at here is running the same thing that we did before, right? We're going to run our Terraform 13 upgrade just to get our version.tf file. Oops, that pasted twice. Come on, give me a clean paste and go. Okay. So again, same thing. If we look at the versions file, all that it's done here is defined that for this NSXT provider, it's going to give us a more explicit name for it, and it's going to tie us to the VMware one. So we'll do a git add. Okay, it's fixing our line endings here. We're going to do a git commit for updating, oops, adding our version TF vars. Again, just copying and pasting so I can hopefully prevent some of the goof ups. So we're going to git push origin, and we called this add dash NSXT rules. And sorry, y'all, I'm working not on my typical keyboard to try and avoid the clicking over the mic. So this is throwing me off for the layout a little bit. Okay, so we've got everything is good. So we're going to go ahead and do a git push back up to our repository. And now at this point, if we come back to our pull request, we should see we've added our version TF file. We've got the automated job running in the background. So we made it past the init, we made it past the format. Now we're looking into the plan, which, oh, hey, look, our plan succeeded. So it liked the SDDC that we had earlier, which is just not showing us a public IP address, but everything else looks good, right? So our plan shows us that what it should be doing is going through and creating a couple of new rules for our gateway policy, right? So it's going to nuke the existing ones. It's going to add us source groups that are going to use my public IP address to go ahead and do the supply. So everything looks good here. The plan succeeded. So we're going to go ahead and do the merge request. Let's try this out. Okay. Comment, merge the pull requests, confirm the merge. And what we can do here, if we jump into our SDDC wall that runs in the background, hopefully we got enough time to actually see this thing. I forgot to pull it up earlier. So on the management gateway, I created a rule earlier. And again, this was just kind of getting in here to pre-provision this environment. So I just did allow any from the internet to vCenter on HTTPS to this SDDC. I did this just because I had to get into the environment earlier and upload a single ISO and then use Packer to just go build an Ubuntu template that it's going to use to stamp out a new VM from this template. So this is what we have existing right here. This is what was pre-provisioned before we're running our Terraform code. And now we're going to go ahead and take a look to see everything looks like it succeeded. Let me get back into my actions and take a look at what the results were. Ooh, merge pull request. It did not like that. So apply. Failed to create public IP. Ah, so my resource with default ID exists for the policy. So it's not liking my firewall rules when I'm trying to put these in with default. And I had this issue once before, but I got it resolved in the last 3 times that I ran this. So unfortunately, we might be stuck here, but I think we're at the end of time anyway. So congratulations, this didn't work. I'll get the working version of the code and everything up for everyone for y'all to see later on. Sorry, this ran to the end of time and you guys didn't get to see the NSXT rules and the VM get deployed, but hopefully y'all understand this is really just the workflow. It's got automated checks in place to catch simple things or make sure that your formatting on everything is there. So yep, that's it, guys. Hopefully this helped some folks out and all this code will be available online later on. Thank you all.
Thanks, everyone.